Well, hi, this is Dr. Shawanda Thomas, math instructor at Lawson State Community College, and in this video presentation, I will discuss opposites and how to recognize them. So what are opposites? Opposites are numbers that are the same distance from zero on the number. So for example, the numbers -1 and 1 are considered to be opposites. The numbers -2 and 2 are considered to be opposites. The numbers -3 and 3 are considered to be opposites, and so on. So those numbers are equal distance from the origin. What you need to know about opposites is that if you divide them, it results in -1. So for example, -6 divided by 6. What does that equal? That equals -1. Or let's say 5 divided by a -5. Those two numbers are opposites. It still equals -1. Or for example, let's try 2 and put a negative here on the side. -2 divided by 2 or -2 divided by 2. It's still -1. Okay? So as long as you have a negative sign, you have the same numbers and a negative sign there, the answer all results in -1. So dividing opposites result in the answer -1. Some expressions. For example, x minus 2 divided by 2 minus x. Now if you look at the numerator denominator, first glance it looks as if those are the same expressions, but they are not. So notice in the numerator that x is positive. So x is considered a positive here. Okay? But look in the denominator. The x is not positive, it's negative. Alright, notice the 2 in the numerator. The 2 here is negative. But in the denominator, the 2 is positive. So when you have a difference in signs here from the numerator and the denominator. In the numerator, all of the signs are different from all of the signs in the denominator. Then you have an example of opposites. So what I'm going to do is rewrite the very bottom. I'm going to write x minus 2 back over, but I want you to see or pay close attention to what I'm going to do, how I'm going to manipulate the denominator. So 2 minus x, let's look at that. Now would you agree that 2 minus x is the same thing as -x plus 2? Yes, because all I did was just put the x first and I carried the sign, which was the negative sign, and I put the 2 last and I carried the positive sign that is considered to have in front of 2. So 2 is positive here, x is negative. All I did was rewrite the x and 2, but carry the signs that were in front of those terms. And that's the correct way you should do it. You should always carry the sign that is in front of the terms. Now would you also agree that if I factored out a -1 here, then if I factor out that -1, I will have x minus 2 inside the parentheses. Now here, yes, because if I multiply negative times everything inside the parentheses, I'll get back -x plus 2. So it turns out that 2 minus x is the same thing as -x minus 2. So I'm going to rewrite this as -x minus 2 back up here in my problem. Now notice I have similar factors. I have common factors here. And because they are identical, basically I can divide out the common factor. So basically we can say we can cancel these x minus 2's. But of course, we say cancel, but really we're dividing x minus 2 into x minus 2, which leaves you 1, and the x minus 2 into x minus 2, which leaves you 1. There's always a 1. And since we have a negative here, we basically have a 1 divided by a negative 1, which gives us negative 1. Let's try x squared minus 6x plus 8 divided by 4 minus x. Now we want to simplify this expression. So simplify the rational expression here. Alright, so what you should always remember is that you cannot cancel terms. You can only cancel factors. So in the state that it's in right now, you cannot do this. Cancel this x with this x, or this x squared, or you can't do that at all. So remember that you must factor first. So how do we factor this trinomial in the numerator? Well, since the leading coefficient is 1, we can just go ahead and put our set of binomial parentheses here, and we have x and x, factors of 8, that if we add them up, we'll get negative 6. So that would be a negative 4 and a negative 2. And we have this 4 minus x on the bottom. Now, if you look at this carefully, you'll realize that these are not the same. X minus 4 is not the same as 4 minus x, because the signs are totally opposite from the numerator and the denominator. They are called opposites. Here, let me do a side note for 4 minus x. Now if we change that 4 minus x, it's the same thing as negative x plus 4. So all I did again was rewrite 4 minus x in descending order, and now I'm going to factor out negative 1. Because if I factor this out, I get the x minus 4 that's in the numerator. And that's what I want. I want to see that they're both canceling out. So it turns out we have x minus 4 times x minus 2. In the denominator, really what we have is negative x minus 4, since that is the same thing as 4 minus x. Now, can't you see that the x minus 4's cancel out? Yes. Now, we say cancel out, but what's really at the bottom here? We have this negative here, and of course there's a 1 here and there's a 1 up here. So basically we have an x minus 2 divided by negative 1. So you can bring that negative sign up. So this negative sign, you can take it up, and now you can make it negative x minus 2 in parentheses, such as that. Or if you would like, I don't recommend it, you can say negative x plus 2. I will take both answers. Try x squared minus 9 divided by 6x minus 2x squared. So in the numerator, instantly you should recognize the difference of squares. The reason why is because you have a difference, you have the minus sign. That's what difference means, subtraction. And you have perfect squares here. That's why they call it the difference of squares. Perfect squares meaning something times something equals x squared, something times something equals 9. So what times itself equals x squared? X. What times itself equals 9? 3. And the format is plus minus. Now in the denominator, we always look for the GCF first, of course. So I see a GCF. It looks like 2x. If we take the 2x out, we have 3 minus x remaining. Now again, it looks like it's the same thing here, but it's not. Are they opposites? Yes, because in the numerator x is positive, in the denominator we have the opposite sign. In the numerator we have a -3, but in the denominator we have the opposite sign. Therefore, they are opposites. Now the shortcut way would be to say, I know that x minus 3 divided by 3 minus x. By now I know that if I divide these out, it equals -1. Okay, so the shortcut way would be just to say, let me cancel both of these out, provided I put a -1 in its place. So I'm replacing those opposites by -1, because x minus 3 divided by 3 minus x equals -1. So all I'm doing is replacing x minus 3 with -1. They are equivalent to each other. Okay, so our final answer is negative times x plus 3 over 2x. Let's write 2x cubed minus 8x divided by 4x minus x cubed. We cannot cancel terms, therefore we must factor first. Numerator, let's see, the GCF is 2x. Take 2x out, we left with x squared minus 4. In the denominator, the GCF is only x, and we're left with 4 minus x squared. What do we see here? I instantly recognize that these are opposites. They look almost the same. They look very similar, but the signs are totally opposite from the top and the bottom. Okay, so since I instantly recognize that these are opposite, I'm going to cancel x squared minus 4 with 4 minus x squared, provided I put a negative somewhere in the problem. Negative represents -1. Okay. Also, I see that I can cancel out this x and this x. So it looks like our answer is just -2. I'm believing that this video presentation will help you out a whole lot.